An object weighing 200 newtons moves at a constant velocity when a force of 100 newtons is applied at an angle of 45 degrees. What is the coefficient of kinetic friction? Go ahead and pause the video and try it for yourself. And once you're done, hit play, and we'll continue. Okay. You can see here I've drawn out the free body diagram. Partial 1, given the knowledge that we have so far. We know the weight of the object, which is 200 newtons, and that is being exerted downwards. We have the angular force that is applied, the 100 newtons, at 45 degrees. And we have this right triangle drawn out because we're going to be using some trigonometry to find this force here. So the first thing we can go ahead and do is remember that the force normal the force normal is equal to the acceleration due to gravity times the mass of an object, or the weight. In this case, we already know the weight, which is 200 newtons, so we can go ahead and just simply draw out our force normal here of 200 newtons. This goes along well with Newton's third law of motion, which states that every action has an equal and opposite reaction. Here we can see the reaction to this 200 Newton force, which is a 200 Newton force in the opposite direction. The next thing we're going to go ahead and do is find this value here. This is an angular component of this force that is being applied. And the easiest way to do that is to use some trigonometry. Here we're going to use cosine because we want to find the adjacent side to this angle, which we're going to call theta. And we know that the cosine of theta is equal to the adjacent side, which is this one, over the hypotenuse, which is this one. Since we know these two values, the cosine and the hypotenuse, we can solve for the adjacent. To do so, we're going to move this hypotenuse over to the other side by multiplying each side by the hypotenuse. That's going to give us the hypotenuse times cosine theta is equal to the adjacent side. Now we know how to find the adjacent side, so we can simply plug in these values that we already have and solve. The hypotenuse is 100 newtons, so we can go ahead and write 100 newtons times the cosine of our angle, 45 degrees. And that's going to equal our adjacent side. Now the cosine of 45 degrees isn't a straightforward number, it's complex. So it's going to give us approximately 0.707. If we multiply that by 100, we get 70.7 newtons, which is our angular component in this direction. Now the reason we did 70.7 and not 70.71 is simply because of our significant figures. We have 45.0, that's 3, and 100 point, just a decimal point at the end, gives us another 3. So we're going to stick with 3 significant figures. Now we know that the object is moving with a constant velocity, which means its acceleration is 0. Now for an acceleration to be 0, that means that the friction and the force in that direction are going to have to be equal. If this force was greater than the friction, it would accelerate and the velocity would be increasing. If this friction was greater, then the object would slow down. Since it is not slowing down or speeding up, we know that the friction in this direction, or the kinetic friction, is also 70.7 newtons. Now, what we want to find is the coefficient of kinetic friction. And if you remember the equation for kinetic friction, which I'm going to write F sub k is equal to the force normal, F sub n, multiplied by the coefficient of kinetic friction. Now this is what we want to find. So in order to single this out, we're going to yet again solve for this. And to do so, we're going to divide both sides by the force normal, which gives us the kinetic friction, which I'm going to draw as a lowercase f just to reduce confusion here. So I apologize for that. Lowercase f here is going to be friction, uppercase is going to be force. So the kinetic friction divided by the force normal is equal to the coefficient of kinetic friction, mu sub k. So in this case, we know both of these values. So we're just going to plug those in. Our kinetic friction is 70.7 newtons, and our force normal is 200 newtons. If you divide 70.7 divided by 200, and you round out to 3 significant figures once again, we're going to get 0.357